Hi, I'm Clark on Temptress. Today we're going to continue our search for the best inexpensive lithium iron phosphate battery around. Today's candidate is the Power Queen 300 amp hour. There is a lot of power in this box. If you've watched my other videos, you know that I'm a sailor and my wife and I travel around, but I'm also an engineer, and I developed this thing called the BankManager. BankManager lets you put lithium in your existing lead system, and I believe it's the only way to properly charge lithium without issues, but that's in other videos. Because I developed that device and people are buying them, they're saying, hey Clark, what lithium should I buy? The lithium I have, I believe, is way too expensive, and I'm trying to find cheaper lithium that look good. So that's what this series is about. Today we have the Power Queen. This is a 300 amp hour battery at 12 volts. That's almost 4 kilowatts, 3,840 kilowatt hours. That's a lot of power in one box. You can buy 100 amp hour batteries and put them together in parallel. But if you have a lot of these batteries in parallel, the wiring between them is different, and they're all seeing a little different charge world. So usually the battery manufacturers set a limit of, it's an arbitrary number quite honestly, but usually like 4, saying you can charge 4 of these in parallel. It's better electrically to put them all in one box under one charge controller, have big cells. That way they're all seeing the world very, very evenly. We know their leads are quite matched because they're bus bars inside the battery. It's easier for you. My advice would be, if you're going to want a lot of battery, and really on a boat, 300 amp hours is a good working minimum. We use 200 amp hours currently, but I'll be upping that number. And the 200 is working for us. We actually even run our air conditioner all night on that 200, along with everything else we do. But we cycle it right down to pretty close to 0 every night. So 300 and up would be a good number for most yachts. If you're a real power hog and you've got lots of solar or generators to recharge it, you might want more. But the point is, a bigger battery or a group of bigger batteries might serve you better than a whole bunch of little batteries. The reason little batteries would still be good for some people would be that you're going to need to put one here and one there and make room for them. The flexibility isn't as good on these big guys. If you do that and you have a lot of them, use really big wire between all the batteries so they all electrically see the same world. So let's talk about the Power Queen. I'm going to start with the manuals. If you watch the Redodo video, you're going to realize there's a lot of same here. And we already know that there's battery companies in China that make batteries without labels and such, and then other people put the labels together. I think we might have found 2 of the same battery, and if it is, this is good, because I think the Redodo was a great battery. And the Power Queen has basically the same manual. It's not identical, but it's also written really well. As I said with the Redodo, it's obvious whoever wrote this stuff had English as their first language. It's very clear, very understandable. There's things to learn in this manual. Get the manual. You get a quick start operating thing for people that are, don't read manuals, and you get lots of stickers. That seems to be the other thing. Let's look at the battery. This Power Queen has essentially the same case that the Redodo had. It's bigger, of course, because there's more battery inside, but everything is where it is. The handles are the same way. The Redodo didn't give me any terrible hassles opening up, so I'm hoping I don't have hassles opening this guy up. Let's measure it. I get a length right to the outside edge of 20 3/4 inches. Since I could just flip this tape over, is about 53 centimeters. For the width, I guess I would call that about 10 1/4, 27-ish. For the height, I'm going to measure to the deck. I'm not going to measure up to these poles, so allow room for where you're going to put your wires, but a lot of people might be able to shove it in under something with this exposed. So this is an important number. And I get just a skosh over 8.5 inches, which is on the order of 22 centimeters. These guys would need like another inch or so. We took a quick look at Amazon and they disagree with me, but I think maybe they're not measuring all the flanges. Like this width is just a little wider down here, but the widest is what you need to know. And as of August 15, 2023, this is the price on Amazon. Next step is I get this top off somehow so that we can see what's going on inside. Let's hope this is an easy one. Well, got it open. It's similar to the Redodo. It uses the kind of seam all the way around with silicone in it. And this one, as an added bonus, has these little lockdowns, these little, kind of like a big version of what you'd see on a laptop computer. That made it extra special to get apart. Had to sacrifice a few of them, prying them open. But it'll go right back together with the silicone. Okay, let's open it up the rest of the way. Ah, man, this is heavy. There we go. All right. I'm gonna right away make the wires safe because we got a lot of power here and I don't want to die. First off, I just was thinking, because I'm about to put metal tools near a battery. I'm wearing metal. Can't be doing that. If you ever mess with batteries, lithium in particular, make yourself safe. Obviously you need to use metal tools because, you know, metal. But think about what they're touching. You're going to be touching the hot. You cannot let the other side touch the negative. It's not like you're going to get a little spark. This is going to be bad. It might weld right there and set the thing, you know, the wires on fire. You definitely want to remove any rings or watches or any metal that you carry on your body. Probably would remove my glasses, but I'm old, I need them. So here we go. I'm gonna take the lid off the wires so that I can put tape on them and make them a little safer. I know you can't see this, but you'll see the after effect in a second. Okay, before I tape up this last guy, let's just take a quick look. What do we have here? We have 4 8-gauge wires with a little extra insulation. Got this shrink wrap thing on the end over a terminal. We'll put it all back together, and when we run our real power through it and take a look at it with the thermal camera, we can all guess, and we could even do the math about how much voltage drop and watts are lost in, how much heat, but there's nothing like looking at it with a thermal camera. It tells us what is. Okay, I'm getting my first real view of it now. Make a little room. You know, it looked like the Redodo, has manuals like the Redodo. Honestly, it smells like the Redodo. I think this might be very similar. And if it is, that's a great thing. BMS says Power Queen on it. So that might mean it's their own BMS, or it might mean that they, you know, had it kind of custom made for them, but it's a sticker. It says SH201F0B663X6.0. That's probably the important number. I imagine the next one is the serial number for this unit. It is a 200 amp BMS, even though they're 300 amp hour batteries. Usually, you know, you want the BMS to be big enough, but really the BMS is based on your needs or what you expect from this battery. And a lot of people are very well served with 200 amps. 200 amps is a lot of power. And then the 300 amps behind it to actually be the fuel tank, as it were. I guess you could say this is like the carburetor and this is the fuel tank. It's a little different how they built it. The battery's held together with some kind of a steel clamping system. And let's see, wasted space, because that's kind of been the thing I've been droning on about. Not really that much. There's about an inch here and here, but the bus bars are using that space to be where you clip on the wires. I would want a little space all around, because if you hit this with something, even if it punctured a bit, it's like the crash helmet. That space is a lot of the protection. We certainly wouldn't want our cells punctured by a little accident. Now, I think they used up all the case with these batteries. Let's take a look at the cells. I'm not pulling the battery out. It weighs 60 pounds. And I'd have to overcome the weight of the battery. Plus, if it's the Power Queen, there's a sticky tape on the bottom and a lot of friction. If I can get the information I need without doing that, I think we're going to do that. Okay, let's take a look. Wow. So cells, 1, 2, 3, 4, 8. So again, they're in pairs of 2, so they're 150 amp hour cells. They're this laser welded or whatever it is that bonds them on there. The wires, again, yep, they're all 8 gauge, 4 of them on each side, and 4 of them coming up from the battery to the BMS. Bring it back down for safety here. Okay. That's the thermal shutoff. It's bonded right onto the side of the battery cell. I am going to go in with a metal tool and remove it. See what kind it is. As we've learned from other battery teardowns, and it'd be good to look at the other ones, even if you're sure this is the battery you want or something. I talk about stuff, and I don't want to repeat the same stuff every time. So there's stuff to be learned in these videos, usually. You might want to watch the whole thing. There's a playlist that would get you through all of them. Also, we have this leaderboard, and you'll find a link to it in the description below. I highly recommend you go down and take a look. It will have all the batteries that I've reviewed, including this one, and it's growing all the time. You'll be able to compare the batteries at a quick glance. Also, if I change my mind, I'll update the leaderboard. I can't redo the video. And I guess finally, there's a link to where to buy the batteries. Some of the battery companies just sell on Amazon, so we'll put a link on Amazon. And if you use our link, you know, we're going to get a couple dollars off the manufacturer's side. It won't cost you anymore. So please. But sometimes I'll put a link to a right to the manufacturer, and that's only if they give me a coupon to save you guys a few bucks. What do we have? 75C. Yep. This is a thermal switch. So this guy is just a switch that when he goes above 75 degrees Celsius, he clicks and shuts down everything. And then when he cools down, he opens back up. Since it's a switch like that and not a thermometer, a thermal pickup, you know, whatever, there's ways to do it. We know this guy does not have cold weather shutoff. Let's see what information I can get right from the cells. They have these stickers on them, and they say, for you guys that like to look this stuff up, 03 HCB 01 BO on the top line, and on the bottom line BRC 6J 05083. I'm not one for chasing down the cells yet, because honestly I don't know a lot about which ones are supposed to be good and which ones are supposed to be bad. I'm going to kind of assume chemistry's chemistry, but they look good, they look new, they're shiny. Okay, next thing we're going to do, as we do, is we're going to check out how the BMS operates in an overcharging situation. I've already charged this with my BankManager to 100%, according to the BankManager, which is where the voltage hasn't started hockey sticking, going up yet. But if I keep charging, that will happen, and if a cell voltage goes above a certain level, the BMS will shut things down. If you're one of the people that is charging your battery until your BMS says stop, please stop doing that for the sake of your batteries. These are like the protection from absolute instant failure. It is not how the battery should be charged. So you want to watch that. But the reason we're going to take this thing through a full charge cycle all the way to the top is at the top, when it starts hockey sticking, if we have one cell that's well behind another as they go up, their voltages will be much more different. And I can check all the individual voltages as that's happening, and we can learn something. So what we're going to do is use Temptress's bench power supply here and give this some charge. I'll put my meter on it so we get to watch. Guess I'll take one of these tapes off. And this time I'm going to turn the power supply on first so I don't get a big spark. Turn up the voltage a bit. What's this guy at? 13.39. We'll start it at 14.5. And I'll turn the amps all the way up. This doesn't go very far. Maximum here is just a skosh over 5 amps, doing 5.1 amps. So it's charging. We should see the voltage come up a bit. We are. Well, we'll let this set. 3, 4, 5. 3, 3, 6. 3, 6, 2. 3, 3, 6. Okay, so the lowest cell is the last cell in the series. That's 3363 right now. And the highest is 363. So that's 3/10. 3/10 is a bit much. So, next step. Well, this guy's still all charged up. I can see the whole top of it. I'm gonna take this into the other room. We're gonna hook it to my inverter. It's rated, even though it's a 300 amp hour battery, the BMS is only a 200 amp BMS, so we can't draw any more than that. And we're going to draw 200 amps out of it and take pictures of it with the infrared camera and see what gets hot, see if it has any issues, and see what its voltage comes down to. That voltage comes down to turns out to be a really good indicator of the resistances of possibly undersized wire or bus bars, and how well the cells can really put out power. I got a feeling, since this guy has such big cells, that cell putting out power part's not going to be an issue for it at all. So, I don't know, I'm interested to see what the voltage is. Let's go back to the aft cabin and take a look. I'm all set up back here. I'm going to rush a bit because I actually have one heat gun currently running. We have the battery hooked with its own wires directly to the negative of the inverter. The positive wires weren't long enough, so I've got them going through one of my wires and through this amp meter. So currently we're drawing 120 amps out of it. The voltage is 12.89. Pretty darn good, but let's draw more power because this is a bigger battery. Okay, we're drawing 200 amps now. Can hear the inverter's fan start up. I just put the heat gun outside the cabin because it's August. Even with the air conditioning, it's hot. So let's look at this. We're drawing 198 amps. The batteries are at 12.66, which is a real good number. And well, let's take a look with the flare here and see if anything's getting warm yet. Okay, I'm getting up a little higher so I can look down on it. And what do we see? This wire, which is my wire, is getting quite warm, especially at its end. But that's not part of the battery. That's something I've added. These are battery wires here, and they're cool as a cucumber, really. And these are battery wires. They're a little warm at the low end, but that's because I have a very bad connection done by vice grips. So the hottest thing in the battery itself is 118 degrees, and that's the heat sink. So just starting up, we'll let it go like we always do and come back at it when it's had a chance to warm up. See if anything gets hot, but starting out good. And I gotta say, I like the voltage. Had to make a little adjustment. My wires were getting really, really hot. So I doubled up on my wire. And we're going again, just a skosh over 200 amps. That's residual heat in that one wire. But what's important is everything over here. 120 degrees is the hottest part of the battery, and that's right on the MOSFETs, right where the actual heat is generated for the most part. So, doing well so far. We'll let it run for a bit. Looking down into it, don't see any heat in the cell area. Just those MOSFETs and heat sinks. Barely warm. All right, I just turned off my inverter. It's a really hot day. My inverter kind of cried uncle. It got too hot in there. So it's been 10 minutes. That's a test. Let's see what the temperatures are. Now remember, only the wires in the battery count, and it is getting a little toasty in there. Right on the MOSFETs, right on the switching circuit, it's 140 degrees. That's always got to be a lot hotter than the heatsink. The heatsink is, well, uncomfortable, but I can move my hand. You look at my hand, you can see where it warmed up. The wires that came with the battery look perfectly reasonable and are only slightly warm. Yeah, they're only slightly warm. And the cells, of course, are cool as could be down there. So I think that's a perfectly good pass. What'd we find? Well, in 10 minutes, we find that my inverter's not as tough as this battery. Battery didn't get particularly hot. The wires were absolutely reasonable for the ones inside the case. My wires were quite hot, though technically they're bigger wires. It's just, well, they're wires that came with things like inverters, and they're probably aluminum inside. Things from China, a little dodgy. It's just leftover wire I had around. I'm happy with the voltage that the battery held to. I'm happy with the power it put out, and I'm happy with the temperature. So I would say that's a pass on high current. We're going to now charge it back up with the BankManager to that reasonable 100%. And then I'm going to run it through a long cycle of discharge. If you've watched my other videos, you know exactly what's going to happen. When you see me, I'll be a lot less sweaty because it'll be tomorrow. So since we did the high power discharge and took some power out, charged it back up with the BankManager to 100%, not this high stuff, to where it should be charged to, and then we ran it through a discharge cycle. That took a while. But at the end of that, it said 299 and change amp hours. Well, in the 300 amp hour range, a half an amp hour is nothing. So I'm going to give them credit for full. That's close enough for me. For the rest of the stuff, I'm going to go through the actual leaderboard. It's got everything I need to know. We filled it in already for this battery. Capacity. I gave this a great, as I've said, so great. The cells, I think they used fine cells. I like how they're hooked up. The bus bars are good and big. Nothing got hot in there. Build quality, we're going to bring in the BMS now to the thought of how it all is inside, the foam supports and everything. Give that a great. No real problem with it. It's not your fancy Bluetooth one, but it has all the safety requirements, has a thermal shutoff. It has everything it needs. The case, excellent. Much like the Redodo case, I like how it goes together. The company, well, I give them a great, and I'll give you a caveat here in the video. There was nothing wrong with my communication with the company. Everything made sense, but there was just very little communication. They contacted me, say, hey, can you do a review on this battery? I looked at the battery, looked like a reasonable battery. I said, sure, fine. They said, where can you send it? They sent it to the right address the first time, which I can't say for all the battery companies. And it arrived. It's like no muss, no fuss, but I also didn't have a lot of questions for them because I kind of knew what it was already. The cost to value ratio at the time of the video, I'm going to give that a great. It's a little bit higher price. It's right in the ballpark, but it's a little bit higher price than all the other fancy offerings we have. We've got the offerings that are definitely lowballing, and they are much cheaper. But for the good ones, this is the highest price. At first I thought, oh, well, that's kind of a problem. Maybe it should get downgraded. Anyway, I checked the competitors, and I think the best competitor for the Power Queen is the Redodo. They seem to be the same family. The Redodo 300 is more expensive than this. I think what's happening here is when you get up to the 300 amp hour range in one battery, there's advantages to that, and many people want a bigger single battery. It brings everything under one BMS, or maybe if you had two of these in your boat, two BMSs, where having 6 batteries in parallel, there's going to be issues with them not all charging the same. So it's a good idea. But I think you're up in rarefied territory if you're buying such a big battery. And there just are fewer of them sold, so the price per watt goes up a bit. This seems to be a good price per watt at this size. That's about it. That's my review on the battery. I like the battery. I would have the battery as my battery. I think it's a good choice for the right boat. Doesn't have cold weather shutoff, but if that doesn't matter, it doesn't matter. Doesn't have Bluetooth, but I think most people really don't have any real use for Bluetooth. I think it's just a good battery. I want to really thank you all for watching the video. Particularly, I want to thank you for sharing links to our video. I'm seeing in our YouTube reports that a lot of people, not just these, but all of our videos, are sharing links with friends. If you have a friend that could benefit from something I've said in one of my videos and you send them a link, not only do they come in and maybe become a regular viewer, really appreciate that, but it seems to be a signal to YouTube, hey, this guy's worth listening to, and they promote me a little harder. So thanks so much for that. I really appreciate it. Bye from Temptress.